Okay, so guys, welcome, and today we'll discuss the topic of remainders for JMC exam. What is a remainder? So if I have a number, say my number is 18, and I want to divide this number by 7, then what is the remainder? How do we find that out? So I write 18 like this, I write 7 into 2, 14, and this comes to be my remainder. So guys, this is known as a remainder. This is known as quotient. This is known as dividend. And this is known as divisor. Okay. So, uh, three, four things to note. Number one, this remainder, this number will always be less than this number. So your remainder will always be less than divisor. This is the first thing. Second thing, if this remainder comes out to be 0, what does this mean? This means that this divisor is perfectly dividing my dividend. So if in this case, if my remainder would have been 0, then I would have said that 7 is completely divisible by 18. Okay, so that is how divisibility and remainders, these two are connected. Now let us also try to understand what it means. I mean, what is the meaning of remainder? So guys, just focus on this number. Just focus on this number, which is our dividend. This number is what? This number is multiple of these two numbers, right? Plus remainder. Once again, guys, this is very important statement. This number, which is dividend, is nothing but multiple of these two numbers. So we multiply both of them, we get this number, and plus something. And plus something is my remainder. So this means that this dividend will be this dividend will be nothing but, we can say, we can consider some multiples of 7, or we can consider some multiples of 2. We can say either way, and then we add up something, whatever is your remainder. Okay, so it means your 18 can also be written as 7 into 2 or 2 into 7 plus 4. This plus this plus this. Okay, now guys, suppose I want to find out a number which is a multiple of 2, 3, and 5. How do we do that? So basically we find LCM, but if you haven't studied LCM, it's fine. So if I want to find out a number which is multiple of 2, 3, and 5, so what that number will be? So there'll be many such numbers. So one number will be 2 into 3 into 5, and this is what? 30. So 30 is perfectly dividing 2 also, 3 also, 5 also. Okay, then 60 will also divide all of them. Then 90 will also divide, 120 will also divide. So the smallest such number which is dividing all of them is 30, which is nothing but LCM of 2, 3, 5. So LCM is nothing but smallest multiple of all these numbers. Now if somebody is asking us, give us a number. Listen to this carefully, Soham. If somebody is asking us, give us a number, give us a number over here, such that if I try to divide this number by either 2 or 3 or 5, I get remainder as maybe 2. How do we find this number? So guys, if I multiply this 2, 3, and 5 with something, I will get this multiple. So this multiple, which is dividend, is nothing but this. But I want my remainder to be 2. And what is this? And what is if if there is a remainder, I can straight away add 2 to this, right? Whatever number comes here, maybe this is 60 plus 2, and I get my 62. Now look at this carefully once again over here. Okay. So 7 into 2 created a multiple which was 14, but I wanted my remainder to be 4. So I added 4 to that and it becomes my 18. So you will see many questions where it is asking that what is that number where remainder is 1, 2, 3 and so on. So how do we solve that number? How do we how do we solve these questions and how do we find that number? So the method is we try to find that multiple and straight away add my remainder to that and done. You will get that number. Guys, always mind it. There'll be multiple such numbers, right? For example, in this case, 62 will be such number, 30 plus 2, 32 will be such number, 90 plus 2, 92 will be such number. So you have to figure out in the question what the question is asking, but there'll be multiple such numbers. So once again, if there is a question, once again, that there is a number and I try to divide this number by this, and some remainder is there. How do we solve this? We try to find what is the multiple of these numbers and straight away we add the remainder to it. That's all. That is how we do it. Okay. Next thing and last thing before we go to the questions. Now remainder has got one amazing thing, guys, and you have to appreciate this. Okay. So if there is a number maybe 99, I try to divide this by 7. And what is the remainder which I get? 14 into 7, 98. And my remainder is what? My remainder is 1. Correct? Now guys, what if I write my 99 as 9 into 11? Then what I do? I try to find what is the remainder if I divide this by 7 separately and this by 7. So what is the remainder in this case? I get 2 and I get 4. I multiply them. 2 into 4 because 9 into 11. So 2 into 4. I get 8. Again, I divide this 8 by 7 and I get my remainder, which is 1, which is same as original remainder. So it's very powerful property which is used in remainders, that if there are multiple numbers which are multiplied, we can find remainders individually and then multiply them. You will get the same answer as if original number was multiplied, or the number or original number which we get after multiplication if we multiply them. I'll show you with another example. Okay. Suppose I had to find multiple remainder of, there is a number 199 into 102. It's a very large number. I had to divide this number by 7. So guys, how can I solve this question? 99 divided by 7. I get remainder to be 1. Then 102 divided by 7. I get remainder to be what? 4. And because it's multiplied, multiply here also. So 4 into 1, 4 is my answer. Remember this thing, guys. It's very, very, very powerful. And sometimes, very lengthy questions. For example, if I ask you a question, 1421 into 1423 into 1425, divide this entire number by 12 and give me remainder. How we can do it? I take 1421. I try to divide this by 12. Then I take 1423 by 12. 1425 divided by 12. Okay. So in the first case, my remainder comes out to be 5. In the second case 7. In the third case 9. And I multiply them. Why I'm multiplying them? Because it's multiplication sign over here. Okay. So now what I get? 5 into 7 into 9. Again, I can keep repeating same thing. So maybe what I can do, I can write 5 into 7 is what? 35 into 9. So let's divide again this by 12. Again this by 12. What is the remainder which I'm getting over here? Remainder will be 11 and here it will be 9. Again, I get what? 11 into 9. Because remember the original thing, my remainder has to be less than the number. My remainder has to be less than 12. So I keep on doing it. Okay. So now in this case, 11 into 9 is what? 99. And I divide it by 12. And what is a remainder? What is the remainder which I get? 12 into 8, 96. And 3 is my remainder. By the way, in this case, what you could have also done that rather than making it to be 35 into 9, you could also have done 5 into 63. Then let's try to divide this by 12 and this by 12. So this by 12, your remainder comes out to be 5, and this comes out to be 3. 5 into 3, 15, but remainder has to be less than 12. So again, I divide 15 by 12. I get what remainder to be again 3. Answer will be same. Remember this thing. Sometimes it's very useful, guys. Now, sometimes we can also use this thing to find out whether a large multiplied number is perfectly dividing or not. If my remainder is 0, perfectly dividing, otherwise not, otherwise it is not dividing that number, right? Okay, so that's all from this point, and then now let's start doing questions. First one, it came in 2024, which is the following has same remainder when divided by 3 as it does by divided by 4. So guys, very simple question. In this case, what we'll do, we'll individually look at all the options and we'll try to divide them by first by 3 and then by 4, and we will try to find out the find out the answer. So there is nothing to explain in this. Answer is 25. I'm sure you guys will be able to do it. So why still I put up this question? See how questions keep on repeating. This question came in 2024, and now look at this question which came in 2015. Which is the following will leave same remainder when divided by 2 as when divided by 3. So this time it was 3 and 4. Earlier it was 2 and 3. So this shows how questions keep repeating in exam, and it is very, very important to go through all previous year questions. Okay. Now let's do a good question now. Okay. It says when 180, it came in 2025. When 180 is divided by a positive number n, the remainder is 5. How many values of n can be there? Okay, let's simplify this. So what I'm trying to do, 180, I'm trying to divide by a number n. Okay, and I get my remainder to be 5. This is what is given in the question. Okay, it is asking me that for how many values of n this is true. For how many values of n this is true. Okay. So guys, first thing, n is what? N is what? Give me a second, guys. Yes. N is what? N and something is what? Your quotient q u o is, let me write it q only. Let me write it q only. So guys, what is happening? My 180 is nothing but multiple of n and q, and then I'll add my 5. It means what? That if I subtract 5 from this number, if I subtract remainder from this number, so 180 minus 5, 175, this will be nothing but multiplication of n and q. This is a multiplication of n and q. Now question is, which is given to us, n is a positive number. How many values of n can be there? So now your n can be 1. So 175 can be written as 1 into 75. So value of n is 1. Then what is the next number with which we can divide 75? 2, no, 3. For 3, we can add up these digits. 7 plus 5 is 12, plus 1, 13. So 3, not dividing. The next one is 5, yes, 5 into 5 into 5 into 25. Okay. Now what can be next value of n? Then 6, not dividing because it's not even number. 7, I can try 7 into 2, 7 into 14, then 3, not dividing, then 8, of course not, 9. If it's not dividing 3, how can I divide 9, right? then 10, 11s, and you can check. Okay. The next number is 25 into 5, and the last number is 175 into 1. So the values of n can be 1, 5, 25, and 175. If somebody is asking what can be values of q, your quotient value of q can be this, and this. Okay. So I'm sure you will get a simpler question in the exam. Whenever you think of remainder, whenever you think of remainder, try to create this diagram. Try to create this diagram and then see what is happening. And you'll find it easier to do. Okay. Now, what is a remainder when square of 49 is divided by square root of 49? So square of 49 means 49 into 49. We are trying to divide this number by what? Square root of 49. So 49 square root is what? 7. By the way, it's plus minus 7. But for today, you can understand that it's just 7. Okay. We try to divide this number by 7. So guys, what we can do? Of course, we can stick to our same formula that I'll break it down. So I try to divide this by 7. I try to divide this by 7. So in this case, remainder comes out to be 0. In this case, 0. 0 into 0 is 0. By the way, if there is a number, something is there, if only one number, just one number is making it completely divisible, I need not check other, because 0 when multiplied by anything will make it 0 only. Okay. So correct answer is option A. Okay. Now remember this question. It was there in divisibility class, and what we did that if I try to divide this by 10, this goes away, this goes away, this goes away. Okay. And then we wanted to check divisibility by, I think, what? I think we wanted to check divisibility by, I think 9, correct? I don't know, 9 or 8. I don't remember. Anyway. So guys, now see how fast you can do these questions. 34 into 35 and 45 into 56. We'll check divisibility by 9. So I divide this by 9. I divide this by 9. This by 9. This by 9. So when I do this, I get remainder to be 9 into 37. And my remainder comes out to be 7. By the way, remember it carefully. If I divide 34 by 9, I get remainder to be 7. If this number is just 1 away, then the remainder will also be 1 away, right? Remainder will also be 1 digit away. Why so? Let's discuss this. So if I have got 18, I'm trying to divide it by 7. 7 into 2, 14. It becomes 4. And if I make this 18 to be 19, then what will happen? Again divide by 7. 7 into 2, 4. And 5, and you will see if I add 1 up over here, it will also be get added by 1. Okay, come back. So now remainder is what? 7 and 8. Again multiply 7 and 8. I get what? 56. Again try to divide it by 9. And what remainder do I get? I get remainder to be 2 is my remainder, right? Therefore, this number is not divisible by 9. And now let's check other pair also. It is perfectly divisible. 9 into 5, 45. So remainder is 0. Anything multiplied by 0 will going to make it 0 only, and we have solved this question. What we wanted to find out, we want to eliminate all the option. Okay. So C will be the number which will divide all numbers from 1 to 10. But same question now we have tried to we are trying to do differently, and now you can see how remainders and divisibility rules are sometimes interconnected, and how you can also sometimes if question is whether this is divisible or not, we can also try to find the remainder. If remainder comes out to be 0, done, it is divisible. Okay. Now guys, look at this 2020 question. There is more than one integer greater than 1 which leaves a remainder of 1 when divided by each of all small prime number. So there is some number, and we try to divide this number by 4 smallest prime number, which are what? 2, 3, 5 and 7. And I get my remainder to be what? Remainder to be 1. So guys, So simple. What will I do? If I have to find this number, then this number will be nothing but some multiple of these plus 1, right? Okay. Now, 2, 3, 5, and 7. And what is the multiple of 2, 3, 5, 7? Because all of them are prime numbers, therefore I need not worry about learning LCM. I can straight away multiply them. So 2 into 3 into 5 into 7, and this comes out to be 210. It means this number is nothing but 210 plus 1. So it is 211. What will be next such number? Next such number will be 210 into 2 times 420 plus 1. What will be next such number? Next such number will be 630 plus 1, and so on. We have to find difference between two smallest such numbers. So the difference between these two numbers, which this and this difference will come out to be what? 421 minus 211, it will be 210, and correct answer will be option B. Okay. So, I mean, it's not a remainder question, so I'm skipping it. Okay. So guys, usually you'll find an easier question for remainders. But once again, if I try to sum up, what do we have to understand remainder in case of remainder question? First, try to make out this figure and then see that how this number is multiple of this and plus this. Second thing which we have learned, remainder is always less than this number. Third thing which we have learned, that if it's a large number, if it's such a large number, it is broken into A, into B, into C, whatever way, then find remainder of all of them and then multiply that remainder. If this number comes out to be greater than your divisor, again keep doing same thing and ultimately you will find your remainder. Okay, so that's all for today. Thank you so much. Bye bye. Tata. Soham.